Hello, good day everyone. I'm Madam Lian. Today, we are going to do revision on the topics probability distributions. There are two subtopics in probability distribution, which is binomial distributions and normal distributions. So, let us start with binomial distributions. Do you still remember what you have learned in binomial distributions? Let's revise back the formula that we have learned. The first one is the probability for x equal to r, will be equal to NCR multiplied with p to the power of r times q to the power of n minus r, where your n represents the number of trials, r is the number of success, p stands for probability of success, and q is the probability of failure, where every one of us know that q is equal to 1 minus p because the probability of success plus probability of failure is equal to 1. Other than that, we have learned also the mean is equal to n multiplied with p, and variance is n times p times q, and for the standard deviation is square root of npq. So now let us look at how we can apply all this formula into the problem solving. Questions 1. In a school examinations, 2 students out of 5 students fail chemistry. A. If 6 students are chosen at random, find the probability that not more than 2 students fail chemistry. So from the questions, we know that 2 out of 5 students fail. So our probability P is 2 over 5. And questions A stated that if 6 students are chosen at random, so our value of n is equal to 6. Then we are asked to find probability that not more than 2 students. So not more than 2 students, it means probability of x less than or equal to 2. Right? So we have to use the formula to solve these questions. So we have to find probability of x equal to 0 plus probability x equal to 1 plus the probability for x equal to 2. So by substituting the value of n and r, with the p equal to 2 over 5 and q is equal to 3 over 5 into the equations, we will get the answer 0.5443 from the calculator. Then we move to the questions B. If there are 200 Form 4 students in that school, find the mean and standard deviation of the number of students who fail chemistry. So our n now is 200 because we have 200 students, and the probability P is still 2 over 5. The questions want us to find the mean, and we know that formula for mean is n multiplied with p. So we have to use 200 times 2 over 5, then we get answer of 80. Then to find the standard deviations, we use the formula of square root of npq, and we substitute the value accordingly into the formula. Then we will get the answer is 6.93. Let's move to questions 2. 5% of the supply of mangoes received by a supermarket are rotten. So from here we know that the probability of rotten mangoes is 0.05. So questions A. If a sample of 12 mangoes is chosen at random, find the probability that at least 2 mangoes are rotten. So with a sample of 12 mangoes, we know that our n is equal to 12. And we are asked to find at least 2 mangoes. The probability at least 2 mangoes are rotten. So instead of finding the probability x equal to 2, x equal to 3, 4, and 5, it's easier for us to use 1 minus probability for x less than or equal to 1. So we use 1 minus probability when x equal to 0, which means there's no rotten mango, plus the probability x equal to 1, which means there's only 1 rotten mango. So
by substituting the n equal to 12, okay, and the r equal to 0, p equal to 0.05, and q is 0.95 into the formula. So we will get the answer of 0.1184 from calculator.
Questions B. Find the minimum number of mangoes that have to be chosen so that the probability of obtaining at least one rotten mango is greater than 0.85. So from the statement here, we have to write the probability for x greater than or equal to 1 is greater than 0.85. So for 1 minus probability for x equal to 0 is greater than 0.85. After we arrange the inequalities, we will have probability for x equal to 0 is less than 0.15. The question asks us to find the minimum number. So the n is an unknown. So we have to find the value of n. So by using the formula NCR, where r is equal to 0, p equal to 0.05, and q is 0.95, okay, we substitute into the formula and we will have the inequalities like this. So we know that NCR for any value of n, when we see 0, we will have the value of 1, and 0.05 to the power of 0 is also 1. So we left 0.95 to the power of n is less than 0.15. In order to solve these inequalities, we have to use logarithm. So n log 0.95 is less than log 0.15. And if you notice from the calculator, when you press log 0.95, you will have a negative value. And log 0.15 is also negative. So for a negative value to divide by another negative value, the sign of inequalities have to change the directions. So we will have n is greater than 36.98. So we are asked to find the minimum number of mangoes. So for the first integer, which is greater than 36.98, is 37. Therefore, the minimum number of mangoes that have to be chosen so that the probability of obtaining at least one rotten mango is greater than 0.85 is 37. Right, let's move on to question 3. The result of the study shows that 20% of the students fail the Form 5 examination in the school. So if 8 students from the school are chosen at random, calculate the probability that A, exactly 2 of them who fail. So from the statement here, we know that the P is 20%, which we can write it is equal to 0.2. And the Q will be 1 minus 0.2, it is 0.8. That means 20% of students fail and 80% of the students pass the exam. Right? And we are asked to calculate the probability of exactly 2 of them fail out of the 8 students. So when n equal to 8 and the r is equal to 2, we substitute into the formula. Okay, to find the probability for x equal to 2, we use 8c2 times 0.2 to the power of 2 times 0.8 to the power of 6. So by pressing a calculator, you will get the answer 0.2936. For the questions B, we have to find the probability that less than 3 of them fail. So less than 3 students fail, we have to write the probability for x less than 3, which is probability x equal to 0 plus probability x equal to 1 plus probability x equal to 2. So by substituting the value of n and r and p and q into the formulas, okay, we use calculator to find the answer, we will get 0.79691. Okay, if the questions ask you to put in 4 decimal places, you have to round off to 4 decimal places. Okay, the last example for binomial distributions. Questions 4. In a survey carried out in a particular district, it is found that 3 out of 5 families own LCD televisions. If 10 families are chosen at random from the district, calculate the probability that at least 8 families own the LCD televisions. So, the probability P is 3 over 5 because 3 out of 5 families own the LCD televisions. And 10 families are chosen at random, so our value of n will be 10. And the probability P is equal to 0.6 and Q will be 0.4. So we are asked to find the probability that at least 8 families. So at least 8 families own an LCD television is including probability for x equal to 8 and probability x equal to 9 and probability for x equal to 10. So by substituting the corresponding value of n, r, p and q into the formula, we will get the answer 0.1672. Alright, after the 4 examples of binomial distributions, I guess you really know how to use the formula. Right, let's move on to normal distributions. If you still remember, the graph of the normal distribution is in a bell shape and it is symmetrical at x equal to mean, right? And the area under the graph is equal to 1. Then this continuous random variable x, we have to standardize it into z. So how to change the value of x into z? We use the formula z equal to x minus the mean over the standard deviations. After we standardize it, okay, the standard normal distributions is distributed with the mean equal to 0 and the variance is equal to 1. So this is the variance, okay, and not standard deviation. So if let's say you are given the value of standard deviation, you have to square it to get the variance. So remember, a standard continuous random variable is z equal to x minus mean over standard deviations. And for sure, during your exam, you will be provided with the normal distributions table. Alright, let's look at example of normal distributions. Questions 5. The diameter of oranges harvested from a fruit orchard has a normal distribution with a mean of 3.2 cm and a variance of 2.25 cm. Calculate the probability that an orange chosen at random from this fruit orchard has a diameter of more than 3.8 cm. So, let's look at the solution for A. We know that our mean is 3.2 and the variance is equal to 2.25. So to get the standard deviation, we have to square root the 2.25 to get 1.5. And we have to find the probability of the orange, which has diameter more than 3.8. So we have to write probability P for x greater than 3.8. And we have to standardize the value of x. So from x to z, we have to use 3.8 minus 3.2 over 1.5. Then you will have to find probability for z greater than 0.4. You can use a calculator or use the normal distribution table to find the value 0.3446. Then we move to questions B. The value of K if 30.5% of the oranges have diameter less than K cm. So you have to write P for x less than K is equal to 0.305. Right, so from the standard normal distribution table, you have to find 0.305, okay, is actually the value of z is 0.15. Okay, if you refer to the table, you will have value of 0.51, but it's because that is less than 0.305. 0.305 will lies on the left hand side of the bell, so the value of 0.51 will be negative 0.51 because this is a symmetrical bell. So our k minus 3.2 over 1.5 will be equal to negative 0.51. So the value of k will be negative 0.51 times 1.5 plus 3.2, and you will have the answer for k, 2.435. Alright, let's move on to the next example. Question 6. The masses of tomatoes in a farm are normally distributed with a mean of 130 grams and standard deviation of 16 grams. So tomato with a weight more than 150 grams is classified as a grade A. So question A. A tomato is chosen at random from the farm. Find the probability that the tomato has a weight between 114 grams and 150 grams. So to answer questions A, we have to write the mean. The mean is 130 and standard deviation is 16. So to find the probability for x in between 114 and 150, we have to standardize it to be z. So we use 114 minus 130 over 16 and 150 minus 130 over 16. We will have probability for z in between negative 1 and 1.25. By referring to the bell, okay, we know that we want to find the area in between negative 1 and 1.25. We have to use the total area under the curve, which is 1, to minus the probability for z greater than 1 and minus the probability for z greater than 1.25. So we refer to the binomial distribution table. You will see that the probability for z greater than 1 is 0.1587. And for probability for z greater than 1.25 is 0.1056. Right? So by pressing your calculator, you will get the answer 0.7357. Okay, let's look at question B. It is found that 132 tomatoes in the farm are grade A. Find the total number of tomatoes in the farm. Right? So the probability of getting a grade A tomatoes is probability for x greater than 150. After we standardize it, you will have probability for z greater than 1.25. And again, we refer to the table. For probability z greater than 1.25, we will have 0.1056. So if the total number of tomatoes is n, 0.1056 multiplied with the total number n will be equal to 132. Therefore, we can find the value of n by dividing 132 with 0.1056. So our n is 1250. Okay, let's move on to question 7. In a boarding school entry exam, 300 students sat for mathematics test. The marks obtained follow a normal distribution with a mean of 56 and a standard deviation of 8. So A, find the number of students who passed the test if the passing mark is 40. So we have to write the information given. So X distribute normally with the mean of 56 and standard deviation of 8. So we are asked to find the number of students who pass. So the passing mark is 40. So we have to find the probability for x greater than or equal to 40. Then after we standardize it, we will have probability for z greater than or equal to 40 minus 56 over 8, okay, which is negative 2. So in order to find the probability for z greater than negative 2, which is on the left hand side of our bell, we have to use 1 minus probability for z greater than 2. So by pressing the calculator, okay, you will have the value of 0.02275. Alright, so we use 1 minus 0.02275, we will get the probability of 0.9773. And when we want to find the number of students who pass, we have to multiply it with 300. And from here, we will have 293 students. Right? Besides using the table, the normal distribution table, we can also use calculator to find the probability. But different model of calculator, you will have different way of pressing it. Right, so this one you have to explore it by yourself. Yeah? So remember to explore your calculator before you know how to get the value from your calculator. Right, let's move to B. If 12% of the students pass the test with grade A, so find the minimum marks to obtain the grade A. Right, so let the minimum marks to obtain grade A be K. So probability for x greater than or equal to K is 0.12, which is 12%. So we standardize the K. Okay, we will have K minus 56 over 8. Right, so from the distribution table, you will have that area 0.12 is the Z will be 1.17. So if the area is 0.12, we will have the value of Z 1.17 by referring to the normal distribution table. So K minus 56 over 8 is 1.17. So K will be 1.17 times 8 plus 56. From there, we get value of K is 65.36. Thus, the minimum marks to obtain the grade A is 66. Questions 8. A survey is carried out about a red presence in a school. It is found that the mean of the number of red presents is 315 and variance is 126. And the probability that the students participate in red presence is P. So number 1, we are asked to find the value of P. We have the information of mean is 315 and variance is 126. We know that the mean is NP. So NP equal to 315 and variance is 126. Variance is NPQ and we know that Q is 1 minus P. So NP times 1 minus P is equal to 126. By substituting the value of NP equal to 315, we have 315 times 1 minus P equal to 126. So 1 minus P will be 126 over 315. So we will have 1 minus P equal to 0.4, where it gives us the value of P equal to 0.6. Right? So this is how we get value of P. Question 2. If 8 students from the school are chosen at random, find the probability that more than 5 students participate in red crescents. So we have the value of N is equal to 8 and the value of P is equal to 0.6. We have to find probability that more than 5 students participate in the red crescents. So for more than 5 students, we have probability of x equal to 6 plus probability x equal to 7 plus probability x equal to 8. So by substituting the corresponding value of the N and the R, okay, with the value of P is 0.6 and Q is 0.4 into the formula, so you will have the value of 0.3154 by pressing your calculator. Right? So let's move to questions B. The mass of fertilizer used in an orchard farm is normally distributed with a mean of 5 kg and variance of 0.8 kg. Find the probability that on a particular day, more than 6 kg of fertilizer is used. So we have to find the probability for x greater than 6. So after we standardize the x, we have the probability for z greater than 6 minus 5 over square root of 0.8. Beware of the value of variance. We are given variance is 0.8. So we want to use the value of standard deviations. We have to square root the variance. Right, so we will have the probability for z greater than 1.12. And again, we refer to the normal distribution table. Okay, when the value of z is 1.12, you will have the probability of 0.1314. Alright guys, after the 4 examples, each for the binomial distributions and normal distributions. Now we are going to look at the SPM questions. So I'm going to give you two examples of SPM questions. So the first example, questions 9. 30% of the pen in a box are blue. Charlie picks 4 pens at random. Find the probability that at least one pen picked is not blue. So to answer the questions A, we know that 30% are blue, meaning that we have the value of P equal to 30%, 0.3. And Charlie picked 4 pens at random. So we want at least one pen is not blue. At least one is not blue. So we have to find the probability for x greater than or equal to 1. At least one is including 1, 2, 3, or 4. So instead of finding all the probabilities of P equal to 1, 2, 3, and 4, we use 1 minus probability of x equal to 0. So we will have 1 minus 4c4 times 0.3 to the power of 4 times 0.7 to the power of 0. So by pressing a calculator, you will get 0.9919. Okay, let's move on to question B. B. The mass of papayas harvested from an orchard farm follows a normal distribution with a mean of 2 kg and a standard deviation of each kg. It is given that 15.87% of the papayas have a mass more than 2.5 kg. Number 1. Calculate the value of H. So, we have a mean of 2 kg and standard deviation of H. So let our standard deviation be in terms of an unknown H. Then we are given that 15.87% of the papaya have the mass more than 2.5. So we put it in the mathematical sentence. P of x greater than 2.5 is equal to 15.87%, where 15.87% is 0.1587. So we have to standardize the value of x and let it be z, right? So we will have z greater than 2.5 minus 2 over the h, right? Then from the graph we know that when the area is 0.1587, we need to find the value of z. So we refer to the distribution table. We will have 0.1587 here, okay, and the value of z is 1. Therefore, this is 1. So the probability for z greater than 1 is 0.1587. Therefore, 2.5 minus 2 over h will be equal to 1, and we will have the value of h equal to 0.5. Okay, then we move to questions 2. Given the number of papaya harvest from the orchard's farm is 1,320. Find the number of papayas that have the mass between 1 kg and 2.5 kg. So we have to find the P in between, for x in between 1 and 2.5. So we standardize it. We will have a probability for z in between -2 and 1. So again, okay, we use 1 minus probability for z less than -2 and minus probability for z greater than 1. So for probability z greater than 2, refer to the table. We have when z equal to 2, the value is 0.0228. And when z greater than 1, we have value of 0.1587. So we use 1 minus 0.0228 minus 0.1587. You will have 0.8185. So to get the number of papayas, we have to multiply the probability with the total number of papaya, which is 1,320. So out of the number of 1320. Okay, we have 1080 papayas, okay, which have the mass between 1 kg and 2.5 kg. Alright, let's move to the last questions. Questions 10. It is found that 60% of the students from a certain class obtain grade A in English in O-level trial examinations. So, if 10 students from the class are selected at random, find the probability that exactly 7 students obtain grade A. So, let's look at A1, right? We have to find exactly 7 students obtain grade A. We have n equal to 10 and our probability of P is 0.6, which is 60%. So with our Q is equal to 0.4, we substitute the value into the formula. We will have probability for x equal to 7 is equal to 10C7. Out of 10 students, we choose 7, okay, to get A. So 0.6 to the power of 7 times 0.4 to the power of 3. So by pressing a calculator, you will have 0.0860. Right? And for number 2, we want to find the probability that not more than 7 students obtain grade A. So not more than 7, meaning that the most is 7. So we have to find probability for x less than or equal to 7. So we use 1 minus probability for x greater than 7. So it is 1 minus probability for x equal to 8 minus probability for x equal to 9 minus probability for x equal to 10. So by using the equation of binomial distributions, we substitute accordingly the value of n and the c and the r with p and q. We will have the answer of 0.8328. In part B, diagram below shows a standard normal distribution graph representing the volume of soy sauce in bottles produced by a factory. It is given that mean is 950 centimeter cube and the variance is 256 centimeter cube. So if the percentage of the volume more than V is 30.5%, so find the value of V. So let us look at the bell. So 30.5% is the area under the curve. So we have to find the probability for x greater than V, okay, which is equal to 30.5% is 0.305. So after we standardize it, we will have probability for z greater than V minus 950 over 16. Because the variance is 256, therefore when you square root the 256, you will have the standard deviation of 16. Right? So we will have probability for z greater than 0.51 is equal to 0.305. We get this value from the normal distribution table. So you have to find from inside out. 0.305 is here, and then the value of z will be 0.51. So from here we know that our V minus 950 over 16 is equal to 0.51. So to get the V, we use 0.51 times 16 plus 950. So that's our answer, 958.16. Right? For number 2, the probability that the volume between 930 centimeter cube and 960 centimeter cube. So we have to find the probability. So first of all, we standardize the x to become z. Then we use probability of 930 minus 950 over 16. And 960 minus 950 over 16, we will have probability for z in between negative 1.25 and 0.625. So again, by referring to the normal distribution table, we look at 1.25. So here's the value of Z, 1.25, okay, which is 0.1056, right? And for the Z greater than 0.625, we look here, 0.62. From here we have 0.2676. So this is 0.62, and then we have to move on to the back 5. So 0.625, I have to minus 16. I have to subtract 16 from 2676. So from here I will have 0.2660, right? So after you press the calculator, you will get the answer 0.6284. So here are all the 10 example questions on the probability distributions, including the normal distributions and the binomial distributions. So I hope y'all can understand, and that's all for today. Okay, good luck and all the best for your SPM. Thank you. Bye.